Volcano Chapter 5 Volcanoes and Life. One day, 100 years from now, a few new forests will be growing on the north slope of Mount St. Helens. Everything that lived on the slope before May 1980 will be able to live there again. For the Earth is a planet of life, and volcanoes are part of the Earth. Volcanoes destroy some life when they erupt, but they also help to make life possible. The Earth has many volcanoes. Some are dead or extinct and will never erupt again. Some are active, giving off lava and gases. Many are sleeping or dormant. They are quiet now, but at some point, they will erupt again. Some of these volcanoes are on the ocean floor. Others are on land. Most of the land volcanoes circle the Pacific Ocean. They run from South America to Alaska to Japan, Indonesia, and New Zealand. Together, they are known as the Ring of Fire. Nearly all the other land volcanoes are in a belt that runs from Indonesia to the Mediterranean Sea. For many years, this belt and the Ring of Fire were a scientific puzzle. Why were most land volcanoes in these two regions? Today, Earth scientists think they know the answer. It has to do with the movements of the Earth's crust. The crust is a shell of solid rock. We live on the crust, but we do not see much of it. Most of it is covered with soil and oceans. Beneath the crust is a region called the mantle. It is made of rock that is very hot. Rock of the mantle can flow like a thick tar. The crust floats on the mantle. Earth scientists used to think that the crust was all one piece, like the shell of an egg. Now, they think it is broken up into a number of huge slabs, which they call plates. Each plate is made up of rock of the crust of the upper mantle. The plates are in motion, moving a few inches each year. The movement is something like that of a belt and a checkout counter. The belt rises in one place, it moves along, carrying whatever is on top of it. It turns down in another place. As the plates move, they too carry whatever is on top of them, the ocean floor, islands, and whole continents. There are places where plates pull away from each other. Here, molten rock wells up and sometimes volcanoes erupt. Over hundreds of thousands of years, the molten rock has built a ridge. The ridge runs through the Earth's oceans, all around the globe, like a seam on a baseball. At this mid-ocean ridge, new material is added to plates that are moving apart. It is like the plates where the checkout belt comes up. There are also places where the plates collide. Here, one plate turns down, as the belt does, and slides under the other into the mantle. Here, rock melts, magma rises, and volcanoes may erupt. This is what happens all around the rim of the Pacific Ocean. In the Pacific Northwest, a small ocean plate is colliding with the big plate carrying North America. The small plate slides under the big one. Here, eruptions have built the Cascade Range. Here, volcanoes such as Mount St. Helens still erupt from time to time. A big eruption seems like a disaster to us, especially if lives are lost. But volcanoes also help to make the Earth a planet of life. Volcanic eruptions and gases to the atmosphere add gases to the atmosphere and water to the oceans. Some Earth scientists think that when Earth was very young, eruptions may have given our planet its first atmosphere and ocean. Volcanoes are builders of land. Floods of lava have built big chunks of continents, such as the Columbia Plateau in the Pacific. Northwest volcanoes build some of the Earth's mountains and some of its islands. They make places where people, animals, and plants can exist. Volcanoes are also makers of soil. Ash, pumice, and other forms of lava break down in time. They mix in with the remains of plants and animals, making a rich soil. The soil nourishes plants, which support many other forms of life. Volcanoes destroy, but they also build. After each eruption, life does come back, finding small footholds and spreading. Natural scientists knew that life would return to the north side of Mount St. Helens, but they were awed by how quickly it came back, by its ability to survive, by the way it appeared in even the most unlikely places. One natural scientist visited the crater after the explosive eruption stopped. At first, he felt like he was on another planet. He was standing in a rocky bowl with sides that rose 2,000 feet above his head. Rock falls kept rumbling down them. Clouds of gases and ash rose from vents in the lava dome. Near him was a rock the size of a small house. The rock, which had erupted from inside the mountain, was a new part of the Earth's surface. A greenish patch caught the scientist's eye. He found algae, simple green plants, were already growing on the rock. He began to walk around it. He saw a ladybug with 11 spots starting to move around as the sun warmed it. He found a wasp laying eggs on the rock. He found flies everywhere. Then he came on a different kind of ladybug with only 2 spots. He found a moth that was the same color as the rock. Finally, he discovered a little opening in the rock where a bird had spent some time, perhaps an evening, There were its droppings, which contained the remains of insects. All this life, the scientists said in wonder, on just one rock. That life, like the island of life and the silver clouds of seeds and insects, was a promise. It was a promise that all the time when St. Helens would be once more be a green and pleasant mountain and home to many, many kinds of animals and plants.